Okay, it's 4 o'clock. Let's start. Do we have, can I get a show of hands of people who were not here for the session 30 minutes ago? Quickly. A couple people. All right. If for some reason you're not familiar with the note well, go check it. I'm not going to run through that again. This is functionally the same session. We're going to jump right into it. Mohit.
Hello, everyone. I'm Mohit. I'll be talking about and giving an update on the internet draft on FlowQPy. So the overview of the draft is that it combines flow queuing and the Pi algorithm, pretty much similar to how FQ combines flow queuing with Codel. And the functioning of FQ is pretty similar to RFC 8290, which is FQ Codel. And the functioning of Pi is similar to RFC 8033. However, there is a small modification that we suggest in our draft. That is, we recommend to use timestamps instead of using little slot to calculate the queue delay. And there are currently 3 implementations of FQPy. One of the implementations is in Linux. There's a separate implementation in FreeBSD, and we also have an implementation of FQPy in NS3. So if we look at the similar kind of AQM algorithms like Codel and FQ Codel, we notice that we have specifications for all of them, Codel, FQ Codel, and Pi. FQPy specification has been missing, and hence we actually wrote this draft. There have been 3 versions of this draft. The first 00 draft described the algorithm. In the next version of it, we updated the scope of experimentation by adding scenarios from RFC 7928. RFC 7928 actually tells us what are the different tests that should be performed when we try to propose a new algorithm. And the latest draft that we updated before this meeting adds text about the FreeBSD implementation of FQPy, which was missing in the previous 2 versions of the draft. So far, we have collaborated with 2 entities for testing the deployment of FQPy in real world. One is a company called Quantum Networks. That's a website, and they have an access point, QQIW235, wherein they have provided this access point, and we have been testing FQPy, and we have shared the results of the functioning to the company, and we are looking forward for more updates from their side. We also reached out to LibreQOS, and they have shown willingness to add the support of FQPy in the next releases. We are also having a discussion about this in the Zulip chat, so please feel free to join there and discuss about it. And we are also looking forward for more collaborations if somebody would be interested to help us in testing real deployment. And with that, I'll stop and just maybe request the TSVWG community to know whether this is the right time to probably go for the adoption of this draft.
Hi, Mohit. Thank you for preparing this draft and presenting it. As you pointed out in the earlier slide, this does fill a gap in the RFC series with respect to some of the available FQ and AQM QDIS. So I think it's a worthwhile thing for us to adopt it personally. Actually, I had one technical comment as well. If you go back to slide 2. You made a minor modification to 8033 using timestamps. That actually raises sort of an interesting trade-off in the implementation of an AQM. In the implementation, you have generally a choice of doing your AQM action at NQ or at DQ. And in Pi, it's generally done at NQ. The downside to doing it at NQ is that your congestion signal goes into the end of the queue effectively, right? And so it's delayed by the queue depth before it transits on to the receiver and eventually back to the sender. But you also have a choice in how you make your drop decisions and what information you use to do that. And the 2 main ways are either sojourn time calculation, using timestamps to effectively measure the queue delay after the fact.
Yeah.
So it can be delayed measurement, or queue delay prediction, which is at the end queue time,
End queue
how
time.
much delay do I think this packet will experience, before it is forwarded on. And back in the discussions in the AQM working group about CODL and Pi, both of them sort of balance each other out in terms of how they manage that. So CODL was doing sojourn time calculation, so kind of a delayed measurement, but the congestion signal was provided right at transmit time effectively, right? The drops were done at DQ.
Right.
And Pi did it the opposite. And in effect, they were kind of balanced, right? But if you change Pi to instead use old information for the control law, and you put the congestion signal in the queue, in effect, you're kind of delaying that process. And I wonder if that's been studied, what impact that has on the performance. I mean, obviously, the control law has got some smoothing of the information a bit, right, with the I part of the PI control, and the update only happens periodically. But just curious if that's something that's been studied.
Yes, there is a study paper that I have also provided a link to in my draft, where we actually reported an issue with the Linux kernel implementation of Pi, particularly when it was using the queue delay estimator instead of using the sojourn time. And we actually fixed that bug in the kernel, and it's upstream already from last couple of years. So the Linux kernel today actually does the sojourn time calculation in Pi and not the estimator. So there's a full article that we published in Computer Networks Journal explaining about the study that we have performed.
Okay, and in that paper, it was studied that the impact of delaying the latency estimate.
Not from that perspective, but we compared both the techniques, that which one will be actually providing you better control in terms of latency, whether you go with the sojourn time estimates or with the estimator, the little slaw estimator that we have.
Right. Yeah. Okay, all right, thank you.
Sure.
So I think last time was it Bangkok, we were kind of talking a little bit of TSVWG was the right home. And after an extensive conversation with the CCWG chairs and our AD, the answer is yes. So if this was going to be adopted somewhere, it would be here, and we'll ask the questions at this time.
All right. So I think it has been there for this is the third time I presented, right? So as we decided, TSVWG at the home. So let's and we got a good comments sometimes, so it is something perhaps a good thing to do. But first thing first, we'd like to know how many of you have read the document. If you can use the tool to vote.
It's a good opportunity. It's a good opportunity for you to scan the QR code that's hanging on the mics if you haven't already.
I think it's stabilized there, or just when I say it, it's going.
Yeah. Is anyone still struggling with the tool? It needs more time. Okay, should we kill it?
Yeah.
Let's kill it. Okay. All right, let the record show that 7. Okay. You could have raised your hands. We're still working on it.
Okay.
Still going.
It's still going on. So. Yeah. Okay.
Oh, it's going down now.
Yeah, it's kind of interesting. Okay.
You had read it, but then it just you cleared it from your memory, and now you don't remember what's in it.
Okay. So I think we're fine. We should stop talking. So yeah, just looking at it.
Okay, is anyone still attempting to vote? I see nothing in the chat. I see nothing, no one raising their hands here, so I'm going to kill it. Let the record show that 7 people claim to have read it, 23 no, and 2 people don't remember if they read it. Okay.
Okay, so I think that tells a bit like, okay, we might need more eyes on the document, so we need to mature and get some more comments. Maybe we are having lack of comments today because people still want to read it. So I think we should do. I mean, we can go for this at a different call. I mean,
Yeah, I mean, so people may not have read it, but I think are at least by now understand what this draft is about.
Yeah.
So maybe we ask the question, as always, we'll confirm on the list.
Yeah. Okay, let's ask the question then.
That was a very good presentation because many people who did not read it think it should be adopted. Does anyone need more time?
It's coming in. I think it is stabilized there. Right.
Okay, I'm going to stop it.
Yeah.
Okay, let the record show 19 people are in favor of adoption. No one was opposed, and 8 people had no. Excuse me, 8 people had no opinion. As always, we'll take this to the list to confirm, but that's a pretty positive, strong signal.
Yeah.
Thank
Sure.
you, Mohit.
Thank you.
All right. Our next presentation is the last one of the day, which may not take us to the next 48 minutes. It is the report, just for those of you who might be a little bit rusty on what was going on here, we have a deliverable to 3GPP for DTLS over SCTP. The SCTP community was quite divided for quite some time about how to achieve this, and we tasked the design team to go work out the differences and find a common approach. And this is the result. And they've been working hard, meeting a lot since Bangkok, and two of the proponents here are going to now present on the result of the design team for the working group's consideration. Let me give you slide control and go.
Okay, I'm Magnus Westlund and Michael here. We're going to talk about this. As Martin said, the design team was kind of locked in to find some compromise by this meeting, or Martin threatened with other procedures. But the design team has managed to come to a compromise and have a proposal for from this design team to present that we're going to present and see that if we can adopt that proposal and going forward with it.
So this is a picture showing the architecture we agreed on. It has a couple of colors, which I will explain. So a DTLS implementation is an important part of this architecture, and we have one functional unit in the DTLS, in a DTLS implementation we want to I want to describe here, and this is what we call DTLS record protector. So DTLS has the DTLS packets are called a record, and they have a sequence number, and they get on the sender side, they get assigned a sequence number, they get encrypted and sent. So that's the sender side of a DTLS record protector. On the receiver side of a record protector, it decrypts the packet and runs a replay protection. So it makes sure that a packet with a certain sequence number is only processed once. This is the receiver side of the DTLS record protector. And what you can see here is on the upper right, what we call a key management implementation. This consists of the yellow part, which is a DTLS implementation, and let's say from a functional point of view, unmodified DTLS implementation, DTLS 1.3. And the only upper layer for that DTLS implementation is a small functional unit running the post-handshake authentication, which is already defined in an RFC, and it runs messages over DTLS. The lower part, the lower blue part, is an SCTP implementation. And what you see here is that you have also a red box, which is called DTLS chunk protector. And this is functionally equivalent to the DTLS record protector, but it has not it has different payload, and it has its own set of parameters. So it has its own replay window, it has its own sequence number, its own epoch, its own variables. But if you have a userland SCTP stack, it allows you to use the same implementation of the record protector for both functions. If you have a kernel stack and a kernel SCTP stack and a userland DTLS stack, you have to replicate this function in the SCTP kernel. We have here green arrows. The green arrows are basically how key material is passed. So we have a key management block in the DTLS implementation, and it talks to the DTLS record layer to give the record protection, record protector the secrets and other cryptographic material to process. And it provides the key exporter with information such that you can export also the secrets. And these exported secrets are then used for the DTLS chunk protector. So the DTLS record protector and the DTLS chunk protector are using different key material. And this all is triggered by the upper layer protocol. So the upper layer protocol can trigger that a post-handshake authentication has to run, or a DTLS connection needs to be set up, or a rekeying has to happen, an extended key update thing. The key management implementation talks to the SCTP implementation, basically giving all the parameters needed for the DTLS chunk protector. So these are the keys, now start a new epoch, remove the keys from an old epoch, this kind of stuff. And since you have data going from SCTP to the upper layer protocol or from SCTP to the key management implementation, this gets multiplexed over SCTP and demultiplexed by the payload protocol identifier. So you can have both directions.
All right, 2 clarifying questions. The post-handshake authentication refers to which handshake? Is it SCTP, DTLS, something else?
DTLS.
Okay, thanks. And did I hear you correctly that really the only like off-the-shelf code here is the DTLS chunk protector, assuming you can't just reuse the other one?
That's what I said. Well, I was formulating a function, an unmodified implementation. So the point is that the DTLS implementation needs to trigger the key exporter and have the interaction with the SCTP level. This might not be in an off-the-shelf DTLS implementation. Okay. So you need to have the hooks for the API, but it's functionally unmodified, assuming that you have the extended key update implemented, which is currently under specification in the TLS working group. John.
Regarding the post-handshake authentication, I see that TIRU has a new draft, 00 draft in TLS, saying that this is a new draft needed to update the certificate using this exporter. This seems to indicate that TIRU thinks that the current solution is not able to update the certificate, and that are we now like depending on some new 0.0 draft?
No. As far as my understanding, is Tiro here? Can he? So my understanding is that the post-handshake authentication runs on top of DTLS. That's an RFC. That's the solution we have right now. That's the solution which goes into the key management document. There is work, what you're referring to do the post-handshake authentication in the DTLS layer.
Okay.
And that might be standardized in the future. And if that is the case, you can modify this key management implementation. You can modify this key management solution. And we have already in the SCTP handshake the facility to negotiate multiple key management solutions. So we can update the document in the future using that internal stuff, and we have the facilities to negotiate that. In the case the key management document is delayed for whatever reasons, and the other document is very fast, it could be integrated, but it's not that we are waiting for that.
Okay, let's continue into some other details now that we have gone through the high level kind of picture, how things fit together. So on the DTLS chunk, so kind of the design principles that we try to adhere here on these two things is for DTLS chunk, we want to be able to reuse the, as we said, the existing record processing in DTLS implementations when you do a user-land SCTP stack. We want to have very clear and simple interaction models with key management and with SCTP stack, and we want to support alternative key management because in some sense we already have it. Requirements on that we have discussed the design team. And we try to keep the impact of the SCTP stack low. And we try to use the facilities that exist in SCTP like parameters for the INIT to signal key management solutions, which we're gonna basically call it called protection solution indicators in this slide set. So on the key management, as before, we have said we're going to use DTLS 1.3 connections as the basis. These post-handshake reauthentication is based on RFC 9261. It uses TLS extended key update to generate new master secrets to derive keys from a rekeying. Using PPIDs to separate the key management traffic. And we also have a new way of trying to address downgrade protection based on the protection solution identifiers in key derivation. We'll go into more detail about that in coming slides. And the message exchange for the key management is solely on top of SCTP using in order reliable messages. So.
Just wanted to say that you're on based on slide count, you're on pace to use the entire time for the presentation itself. So
yeah.
Hopefully it goes a little faster.
Yeah, it will go faster, but we go more on so. But around these hooks, etc., I just want to show how you actually arrive at keys, etc. So we start there on the top with the SCTP normal four-way handshake, and in this initial, you do send the parameter that says, I support the following protection solutions, and you have a preference, and that's in a preference ordered list. The pair selects which of them and return that parameter back. And then you can conclude on the SCTP establishment. So both sides then get saying, okay, what was the protection solution indicator vector? So saying the list that was in the init needs to be learned by the higher layer on both sides. I mean, you first know what is put in, and the second needs to get it out. And then it's in this example, we trigger in the crypto handshakes, the key management handshakes, by the SCTP established completion. And then you send the DTLS handshakes. So when you gotten to a point where you have keys, you start deriving them. But here you do have some you see this purple text, which is start setting the keys into the detailless chunk, and this needs to be done in a certain order so you don't deadlock yourself. Because you can have need for retransmitting these SCTP message before you're starting to actually. So you're sending. You have the send and receive keys on the client side, but then you send the search response and the detailless finish to that peer. At that point, you only set the receive keys, and when the other side then has received, and they know he will have receive keys installed, I can send encrypted detailless chunk now. So that's why the detailless act that goes back there is actually protected by detailless chunk. That's what the brackets around it is. And to do that, it just sets the send and receive keys for this session, allow association. And when it come back to the other side, his received secured message knows that, oh, now I can actually set protection. And also sets the send keys. So any future now will be protected from A side, and he will require the other side to send also encrypted. At this point, any future data exchange or based on sender dry, the other pair can tell its slower detailless chunk saying, from this point, only accept protected detailless, protected SDP packets. So that is how we establish the sessions. Parameter protection solutions indicating which solutions, which key management solutions to support. Also, if you would have another security solution that you would like to offer and have choice between, you could still use this parameter to indicate that I support them, etc. And as I said, responder picks a single solution. So the downgrade, what we've done here is try to prevent an attacker from modifying the unencrypted, unprotected initial handshake. And to ensure that you don't get downgraded in this phase, we're actually going to do so that when we derive the keys, we're actually going to take these PSI vectors and input into the key derivation. So when you run the TLS exporter, you input this data in combined with how your particular key management. And if you do that, if not both sides has the same PSI vector, you will fail. So that way you can protect from no extra SSH changes, nothing of that. You're not vulnerable to the weakest solution being possible to compromise. However, you will not get a clear signal that there was a downgrade, but you get this benefit that it's harder to attack. So, no. So the detailless chunk is an SCTP chunk with and detailless record inside. We're using as much of the detailless record for identifying these. So you have the SCTP association. You know that you have it's a detailless chunk itself identifying, and then you will have a details record inside, which will start with this header depicted on the lower left side. So that way we can see we have the association, and then you try to identify the key context from association, the connection ID if it's included, the epoch, which is the lower 2 bits is as EE on the first byte, and then sequence number is what you then determine, okay, this particular full context special information is what's being decrypted. So you get the right and packets. Yeah.
So this is an overview about the key management, and you see on the right side, well, the ASCII figure from the key management document, which is very similar to the architectural one. So you can see you have the handshake protocol running inside the DTLS and the application protocol. We actually, for the initial key establishment, we run a normal DTLS handshake. The DTLS handshake will also derive which cryptographic algorithms will be used for the DTLS communication, but it's the same which is then used for the DTLS chunk. So it's they are not using different cryptographic algorithms, and there is no SCTP specific negotiation of that. The rekeying is done with an extended key update. We need an extended key update because we derive the keys for the DTLS chunk from the key exporter, and the current key exchange in DTLS does not update what is used for the key exporter. So that's why we need the extended key update. For the re-authentication, we use something which is running on top of DTLS, which is the post-handshake authentication. We need to define there the precise messages to be put in there, but the procedure is defined. We don't need any specification for that. Yeah, so we have defined for the SCTP chunk, for the DTLS chunk, an API. So we have focused on what you need to provide. This means you must be able to identify what key material you want to use in which thing. So for example, for a particular association, for a particular epoch, and so on. And this then needs to be updated when we run the key, extended key update. SCTP restart is an issue. This is happening. So this is basically two sides communicate, one side dies, comes up again and wants to reestablish the communication while the peer has not even detected that the site went down. This feature is needed in this application area, and we want to make sure that this can't be used by an attacker to take over an association. The figure shown here indicates that this new handshake is also protected. I think this will change in the next revision because the SCTP specification requires you to use 0 as the verification tag of a packet containing an init chunk, and middle boxes and firewalls are required to enforce this by dropping any packet with a verification tag of 0 and not having an init chunk. And this would look like on the wire, you see an SCTP common header and a DTLS chunk, and this combination wouldn't work. So the first two messages would be unprotected, but that's not a security issue. There is also the wish to perform this restart pretty fast. So you have to go through the SCTP handshake. The idea is not to go through the DTLS handshake. So when a DTLS connection is set up, a specific restart key material is generated and can be used when restarting. On the server side, this means you need to store another key as you already do. That's nothing special. On the client side, this might mean that you need to store a key such that it survives the restarting of the node. So you might have this capability or you might not have this capability. That's why it's not required to implement this on the client side. Yeah, so this is the API, abstract API context. So that is what you need to provide to the SCTP stack. The current document describes pretty complete, I guess, an abstract API, and it has the starting of a socket API section, which we usually provide for SCTP documents. That will be completed soon. So you see here what's there. So you can provide you can check what is the supported cipher suites. You can set keys, destroy keys. You can require protection, which means SCTP at the beginning will accept protected and unprotected packets. Typically, it won't receive protected packets because the context is not yet there. But the API at one point can say, from now on, only protected packets are being accepted, and you can't go back. And then every unprotected packets, except for init chunks, would be processed.
We have Dan in the queue. Dan? Guess not. Okay.
Okay, so you have also other things like you can configure the replay window because this is something you might to address. The point here is that normally the replay window is configured to deal with the variations of delivery on one path, but this is on the context of an SCTP association, so you have to deal with the differences between multiple paths. So it's a different problem here. The socket API will come, what will be discussed between the Linux and FreeBSD developer, because I think that's these are the people right now working, which have an implementation, SCP implementation in the kernel. And these are the right now individual documents. The first one is describing the DTLS chunk. The second one is describing the key management as is the consensus of, or the compromise of the design team. There is another document from Ericsson describing an Ericsson specific and proprietary key management, which has IPR. There's no IPR declaration on that. The IPR declaration on the DTLS chunk is a one which is around there for a long time. And it has a defensive, what's the term? Defensive style.
Assert. Assert, right? What? Assert.
Martin.
Okay, two questions now. So this IPR declaration does this not impact your ability to implement this, Michael?
Pardon?
This IPR declaration does not impair your ability to implement this proposal?
No, that's fine. It's defensive.
Excellent. Okay. My other question was, so are the actual like SCTP chunk types encrypted by this scheme?
So what is plain text is the common header containing the port numbers and that stuff. Unencrypted is the chunk header of this. Encrypted and the payload is starting with the encrypted DTLS header. So the payload is encrypted. This means all the chunk times you are actually using for communication are encrypted.
Right. Okay. So then why, if you can go forward to the restart thing. Yeah. We'll go back. So why does it, if the fact that it's a init chunk is encrypted, why does the firewall rule about init chunks matter? Because the middle boxes can't tell, right?
So the firewall will see a packet and will look at the verification tag. Mm-hmm. That's in the common header, that's unencrypted.
Yes.
And that's 0 because the init chunk, when you send a packet with an init chunk, the verification tag is 0. You don't know yet what the other side is requesting you to send.
But the middle box doesn't know that it's an init chunk.
No, but the middle box will enforce that packets will enforce two things. First, if there is an init chunk, the verification tag must be 0. Mm-hmm. If there is a verification tag of 0, it must be an init chunk.
Okay,
and
got it.
That's the point which breaks this.
Okay, thank you.
So, so that's the next steps. We have two individual documents coming out of this design group. The request would be to adopt both of them as working group items. The chunk document can progress on its own. It has no dependency on stuff in other working groups. So the idea is to progress the chunk document in this working group, and it will not have a mandatory reference to any key management document. The key management document in this working group can progress at its own speed, and it depends on work in the TLS working group. But the chunk document could be published before the key management document. The key management document will have a normative reference to the chunk document.
Okay, I would like to invite people to comment on any of this. Okay, that's a good comment. Good presentation, somebody said. All right, let's ask the questions. This is fairly hot off the press, I believe, but let's optimistically ask the question if anyone's read these, either of them. I'll take either. Well, I got at least 2 votes back here. Hopefully you guys are voting yes. How many people are on the design team? 5, 6?
6.
Are they all here?
No.
No.
Oh, yeah, excellent. No, I'm just curious if the 6 people were just the design team.
So, but the people in the design group all support this way forward. And we ran all the mails we sent through the design group. So this is neither the opinion of Magnus nor the opinion of mine.
Yeah, thank you for clarifying that. I was just wondering if the people who had decided yes were just the people on the design team. But no, we've passed that number already. Okay, is anyone still struggling to vote?
Gori had the question.
Oh, Gori, go ahead.
Gori, just observing that the design team contained most of the interested parties here. So actually, this is an amazing outcome. I just thank people that they agree.
I just curious if anyone had managed to get to this draft that was not on the design team. Charles,
They did a good job.
Yeah, really happy to see this. Just one question on the dependency in TLS on extended key update. It seemed like there had been some good progress in that, like kind of a breakthrough a while ago that helped bring this option really back to the table. Is that still going well? Has anything significant changed in TLS working group?
So it's a working group document. It has been presented, I think it was yesterday, Hannes? Yeah, it was presented yesterday. So there is really feedback from the working group in the sense, and not in the sense that we don't want this work, but in the sense, can you do this? Then it's a bit better. So it's like positive feedback. So, and it's not only us going there saying we need this. So there are multiple co-authors now on the document, not coming from this background, wanting this feature.
okay, let the record show that 8 people claim to have read one or both of the drafts and 18 have read neither. Would anyone like to articulate the position that we should adopt one of these but not the other? Let's see if I save ourselves some time by asking them jointly. Going once, going twice. Okay, I'm going to ask one question for both. If I can do this. I have to terminate the show of hands first. That's a problem. Okay. While we're voting, if anyone feels that they really need to read this thing and like want to put a hold on it until they have a chance to read it, I would certainly entertain that comment. Just enter the queue if you feel that way. Okay, so no one is insisting they get a chance to read it before we consider this. And of course, we'll take it to the list anyway, so you will have at least a couple of weeks to read this if it comes to that. All right, is anyone still struggling to vote on the tool? All right, I'm going to stop it. The final tally is 16 people in favor of adopting both. No one is opposed.
I think we're going to confirm that in the mailing list.
Of course.
I would like to take the opportunity to thank the design team. I mean, observing it, it was like, it's a very hard work and you have done a really good job. So thanks for doing it. So I have one question to Charles. Charles, I mean, we have a liaison statement, right? So, I mean, now that we kind of like getting this, so what is the next step? What do you think? Like
once we're adopted.
Once we are adopted. So basically, we're gonna do we need to respond to 3GPP-LS or?
If I may comment, I think I mean, we need to send a new LS basically informing them about that there's some progress and maybe some rough outline of when we can expect to have some pieces ready. So
yeah, and to include at least a brief description, I think, of what those two drafts are, so you're not, you know, they don't have to read both real carefully in order to understand what's happening.
I'm going to request the proponents like assist us on composing that liaison statement, and also, I mean, there's a presumptive adoption happening here based on this vote, and given that, I would like you guys to do some serious deep thought about, I don't know what appropriate milestone date is for both of these documents that we can meet, because obviously there's great interest in that.
And I think that one of the design team member can write the LS, because I think you are the best person to write it. So a brief description like what's going on, what's the dependencies and all this thing, then send it back to 3GPP.
Yeah. And my one question would be, is there anything more you need other than just informing them? I mean, this would just be a response I'll ask, but I mean, do you anticipate specific action that you need from them, or do you think you have all the information you need?
I guess it might be for action. I mean, the thing to consider if it's to action, if they want to review it at this, I mean,
they should always review it, but I mean, you're not like, my impression is that we already had enough back and forth that we understand their requirements. We're pretty confident this meets them. So I think, you know, we could just send it as a response, not request any specific action, leave it on them to come back to us if they have concerns.
I think that's the right approach to that. Basically, we send it like, this is what we have done, and inform them. If they have more query, I mean, that will come up with a follow-up.
So we are not looking for any specific information. We need to progress.
Great.
And Charles, you'll handle whatever is necessary in terms of liaisoning with the TLS working group about the draft that we require from them.
Oh, I haven't been, you mean for me to talk with the TLS working group?
Well, I mean,
if we thought there was a concern there, that's kind of why I asked. It seems like things are going fine.
Good. I think we should let it happen.
If it's IETF business as usual.
Well, I don't think we should make promises on behalf of the TLS working group in terms of delivery.
Yeah, I think it's about, if we can try to, as correctly as possible, characterize what we expect from what's in the process, what's remaining, etc. That the fact that we are dependent on others for the key management would be made clear, so that if they have any further, I think we can just inform them about they have this dependency. It's like depending on several pieces of work to complete before you get the actual final complete solution. So, but let's draft the LS so we can discuss this during that process.
I think the TLDR here, basically we have now a consensus, like given that we adopted these things and moving forward, that just inform that.
No, that sounds good.
Okay, well, with the, John wants to, yeah, go ahead.
I will say like TLS, that's progressing great. But like we doesn't need to write anything, but I think this will not happen release 20. Would be my personal view. We don't need to write that. But
Well, it just needs to be clear to 3GPP that there are 3 documents that need to go to RFC to complete this deliverable, and that one of them is not something that we can make any assurances on. And so, like, I think we should have one LS, but I guess you, Charles, probably have the ball to integrate whatever input TLS has for this. Okay.
So to be very honest, we cannot make even insurance for our, like, how long it will take.
Yeah.
We can guess, like, we can guess it. So no insurance, just inform them we have the decision.
Okay, lovely. I think thank you, gentlemen, for all your work on this, as I had suggested. All right, so I think we have 10 minutes back, so you can stake out the cookies a little bit early. You deserve them. And we will see you all in, where's the next meeting? Montreal.
Yeah, Montreal. See you in the colder side.
Yeah.